This video is an overview of the puzzling pedigree assignment for BI 112 students at Mount Hood Community College. Looking at the puzzling pedigree, what you'll notice is up here, the three things that are required for this first section is you're going to be looking at a set of pedigrees and you're going to be matching the disorder with the correct type of pedigree. The type of pedigree the pedigrees that you have are five. There's autosomal recessive, X-linked dominant, autosomal dominant, Y-linked dominant, and X-linked recessive. Once you identify which pedigree is associated with which description, then you'd write a paragraph as to why you chose that. What was your rationale by choosing that? And then on the pedigrees, you will actually identify with the correct symbol. And down here, you can see the symbols, male, female, but also we're going to be dealing with carriers. So it says which one must be a carrier. If it's an autosomal issue, then you would color in either the square for male or the circle for female in half, or representing basically heterozygous, but which means they wouldn't show the disease. So a carrier is someone who doesn't really express the disease, but they carry the affected allele, which means they would be heterozygous. And if they're affected, then you color them totally in. Now, for dominant traits, that could mean that they are still heterozygous, but they show the disease, they express the disease, so you have to color it totally in. If it's an X-linked issue, then you would put a dot for the carriers for that. So anyway, those are the symbols, and that's the requirements for this section. So there's two sections to this assignment. So here are the pedigrees. So your job is to go through these five pedigrees and identify them as either being, autosomal dominant, autosomal recessive, sex-linked dominant, sex-linked recessive, or Y-linked kind of thing. So what you're doing is just going through each pedigree and looking at the characteristics of that pedigree, which has three generations, and trying to identify what are the common characteristics. There is a key. If you go here, you'll notice that there is a key. And basically, it's a process of elimination. So you'd look at under autosomal dominant, you'd look at your pedigrees and say, okay, which pedigree has males and females that are equally likely to have the trait. So pretty much equal males and females. Which ones do not skip generations. So if you see one that does skip a generation, then you would eliminate that as a possibility for autosomal dominant. There's male-to-male transmission. So if you don't see male-to-male transmission, then that would rule out autosomal dominant. So basically, you use these four patterns as a key, and then you go and you basically say, okay, looking at those five pedigrees, which pedigree matches these characteristics the most. Now there is a fifth pedigree, as you know, but it's so obvious that you shouldn't need any help in identifying which one that it is. So again, once you get done with this and you identify them, then there's a section where you're going to list, okay, table or pedigree A is what character, is it autosomal dominant, recessive, X-linked, recessive or dominant, or Y-linked? And then give your rationale. And your rationale can basically be from this pattern of inheritance. So it's not that big of a deal. You can just copy what are the key things that basically you identified that would make it that pedigree. Okay. And here's the pedigree rationale. So list the disorder and what's your rationale behind that. The next section is you're going to be actually drawing a pedigree, so you make sure you get a bigger piece of paper, and then just go through the generations, and you're going to have 5 generations, so make sure you give yourself plenty of room and spread it out. But basically, once again, if they're afflicted, then you have to blacken in the whole square or circle. So if Rigo's afflicted, he would be blacked in, but his wife is healthy, so she's not. Um, okay, and then you basically would connect those. If you look at the past pedigrees, you'll notice that the parental generation is, or whoever has the offspring, are connected together by a horizontal line, and then you draw a vertical line down, and then draw a long horizontal, and then the vertical lines for the generations. So, in generation 2, so you draw a horizontal line between the square and Esmeralda, identify that as Rigo, and Esmeralda, blacken in Rigo, and then draw a vertical line and a long horizontal line where you can put 3 offspring with vertical lines, and then you have the daughter, which is a circle, is afflicted, and then a vertical or a horizontal line to a square, which is her husband, and he's healthy. So she's got a blackened in circle, and he doesn't. So again, you just do that for 5 generations. Um, and then from that information, you should be able to answer these questions. Um, and so you're going to identify based on the genetic disorder what it would be, right? And so it'll be one of those 5 that were given previously. And then, you're going to look at your pedigree, you're going to look if they're afflicted or not, and you're going to have to identify whether they're heterozygous or not. And the way you would do that is just go back a generation. And so if you know that, for example, I can't remember, but if Zelda's afflicted, in order to know if she's homozygous with the affliction or heterozygous, you'd have to go back to the parents. So if one parent is afflicted but the other one is not, uh, then you can make the assumption that she's heterozygous. But if both are afflicted, then you could make the assumption that she's homozygous. That's not necessarily true, but you kind of have to work your way backwards to determine if they're heterozygous, because that's going to make a difference in their offspring, whether she's heterozygous or not. So then you're going to use a Punnett square. So you basically identify the 2 alleles for Zelda, the 2 for Ramon. This is a monohybrid cross. You're looking at one disease, so you make 4 squares and then identify what the gametes are on the left and on the top, and then see what the offspring would be. Then that would give you the probability of the child. So the probability is going to be what percentage of a chance would that child, would the children that they have, what percentage of a chance would they have to have that disease or be afflicted. So you could say they have a 25% chance, 50% chance, or basically 2 out of 4 of the kids. So there's 50-50 chance that the offspring would have the affliction, kind of thing. So you do that for all 4 of these, and then make sure you read the questions carefully and know what it's saying. Don't make any assumptions, but write down what you know and go from there. All right, and that's pretty much the assignment. All right.